Hello friends, I welcome you on my channel Engineering Mathematics djganit. In this lecture we are going to discuss about mean and variance of a Poisson distribution. In earlier lectures we have seen in which situations we can apply Poisson distribution, and we have done enough number of examples on Poisson distribution. Today we will see what is the mean and variance of a Poisson distribution. So before deriving the formula for mean and variance of a Poisson distribution, we just recall what is the formula for mean and variance of a discrete random variable. So this we have discussed in earlier lectures, that if x is a discrete random variable with probability mass function px, then the mean of x is denoted by mu, or it is also known as expected value of x, and is defined as sigma, that is summation over x into value of probability mass function at point x, and this summation is over all possible values of random variable x. And we have seen that variance of a random variable x whose mean is mu is given by expected value of square of random variable minus square of expected value of x. So using these two formulas we are going to derive the mean and variance of a Poisson distribution. So we will show that if a random variable capital X has a Poisson distribution with parameter lambda, then the expected value or mean and variance of x are equal, and the equal value is parameter lambda. So we are going to derive this, that mean of a random variable is lambda, mean of a Poisson random variable is lambda, and variance of a Poisson random variable is also a lambda. So first we derive the formula for mean. So as I discussed, I know that mean of a discrete random variable is defined as summation x into px for all possible values of x. So we are interested in the mean of Poisson distribution. So we know that if x has a Poisson distribution with parameter lambda, then the probability mass function of x is given by this formula, e raised to minus lambda raised to x divided by x factorial, and the range of x is from 0, 1 to up to infinity, or x is any non-negative integer. So in this formula we will put this probability mass function and we will try to simplify. So by definition, the mean or expected value of x is given by this sigma fx. Here range of x is from 0 to infinity, so summation is from 0 to infinity. Now here we put px equal to e raised to minus lambda into lambda raised to x divided by x factorial. Now if you put x equal to 0, then the first term of this summation, the first term of this summation for x equal to 0 is 0 into e raised to minus lambda raised to 0 divided by 0 factorial, and we know that 0 factorial is 1, lambda raised to 0 is 1, and this is also non-zero, so it is 0. So the first term of this summation for x equal to 0 is 0. So instead of writing from x equal to 0 to infinity, we can write from x equal to 1 to infinity also. So here I have written this same summation as summation from x equal to 1 to infinity, because the term corresponding to x equal to 0 is 0. So it does not matter whether we are writing from x equal to 0 to infinity or from x equal to 1 to infinity, and remaining terms are as it is. Now this x factorial can be rewritten as x into x minus 1 factorial. So this x factorial, we can think in this way: sigma x equal to 1 to infinity x e raised to minus lambda raised to x divided by, and x factorial is written as x into x minus 1 factorial. So this x will cancel out, and we are left with this e raised to minus lambda raised to x divided by x minus 1 factorial. Now again we rewrite this x as x minus 1 plus 1, and this lambda raised to x minus 1 plus 1 again can be written as lambda raised to x minus 1 into lambda into e raised to minus lambda and x minus 1 factorial. Now these two things are independent of x, lambda into e raised to minus lambda, so they can be taken outside summation, and we are left with lambda raised to x minus 1 divided by x minus 1 factorial. Now suppose I assume x minus 1 equal to some new variable, say y. Then if I take x equal to 1, y will be 0. If I take x equal to 2, y will be 2 minus 1, that is 1, and so on. So when x is running from 1 to infinity, this y will run from 0 to infinity. So we replace x minus 1 by y, so lambda raised to y divided by y factorial, and if x is going from 1 to infinity, y will go from 0 to infinity. Now this is very famous series of the exponential function. Okay, you might have studied in calculus that e raised to x is nothing but sigma x raised to n by n factorial n equal to 0 to infinity, and this series is convergent for all x to e raised to x. Now instead of x, here we have lambda. Okay, if you compare this series with this series, then instead of x we have lambda, and instead of y we have n. So these are dummy variables. You can replace lambda by x or any other variable. So if we have x raised to n by n factorial, we write e raised to x. So here we have lambda raised to y by y factorial summation y equal to 0 to infinity. So that we write as e raised to lambda. So e raised to minus lambda into e raised to lambda, that is e raised to 0, which is 1. So therefore we have shown that expected value of x or mu is lambda, that is mean of a Poisson distribution is parameter lambda itself. Now we discuss what is the variance of x. So variance of x is given by expected value of x square minus expected value of x whole square. Now expected value of x is lambda, so that we have already find out. So we have to find out expected value of x square only to find out the variance of capital X. So first we find expected value of x square. So by definition, expected value of x square is sigma x square into px, x equal to 0 to infinity. Now x is Poisson random variable, so we put value of probability mass function here, px equal to e raised to minus lambda raised to x by x factorial, and I replace this x factorial by x into x minus 1 factorial, x square e raised to minus lambda, and this x we rewrite as x minus 1 plus 1. Here also, if you observe that the first term of this summation for x equal to 0 is 0. So instead of writing from x equal to 0 to infinity, we can write it from x equal to 1 to infinity. Okay, so that summation index from x equal to 0 to infinity is replaced by x equal to 1 to infinity, because for x equal to 0 the term of this series becomes 0, so it does not matter whether we are writing from x equal to 0 or x equal to 1. And this x will cancel out, 1x will cancel out with this x, so there will be 1x e raised to minus lambda, and this we rewrite as lambda raised to x minus 1 into lambda raised to 1, that is lambda. And this lambda is independent of x, so that we can take outside, and this is x e raised to minus lambda, lambda raised to x minus 1 divided by x minus 1 factorial. Now we change the variable from x to y by the substitution x minus 1 equal to y, so that means x is y plus 1. So here we replace x by y plus 1, e raised to minus lambda as it is, x minus 1 is y, so it is lambda raised to y, and x minus 1 is y, so we have y factorial. Now if x minus 1 is y, then when x equal to 1, y will be 0. When x equal to 1, y will be 0 from this y equal to x minus 1. When x is 2, y is 1, and so on. So when x is running from 1 to infinity, y is running from 0 to infinity. So this summation is replaced by range of y, which is y equal to 0 to infinity. Now we multiply this e raised to minus lambda into lambda raised to y with these two terms of the bracket. So we obtain y e raised to minus lambda, lambda raised to y divided by y factorial, plus 1 into e raised to minus lambda, lambda raised to y divided by y factorial. Y is from 0 to infinity. Now here y is a dummy variable, so instead of y we can write small x also. Okay, so we replace y by another variable small x. X is from 0 to infinity, x e raised to minus lambda, lambda raised to x divided by x factorial. We are replacing small y by x, and this also we can write as e raised to minus lambda, lambda raised to x by x factorial. Now if you observe this, this is nothing but probability mass function of Poisson random variable. So we replace this by p of x, that is probability mass function of Poisson random variable, and this is again probability mass function, so this is also replaced by p of x. Now this is the definition of mean or expected value of a discrete random variable. So sigma x into px is again mean of a given random variable, but mean is lambda, so we will put this equal to lambda, and this is the summation of all the values of probability mass function, and we know that summation of all the possible values of probability mass function is always 1, and this is the formula for expected value of x, and this is plus 1, and expected value of x is lambda, so we obtain lambda into lambda plus 1. Now the variance is expected value of x square minus square of expected value. Expected value of x square is lambda into lambda plus 1, and expected value of x is lambda. Okay, so if we multiply this lambda into lambda plus 1, we obtain lambda square plus lambda, and this is minus lambda square. So lambda square will cancel out and we left with lambda. That means the variance of Poisson distribution is also lambda. So hence we have shown that the mean and variance of a Poisson distribution or mean and variance of a Poisson random variable are equal, and the equal value is lambda, which is parameter of the Poisson distribution. So we consider one example. If x has a Poisson distribution such that probability that x equal to 2 equal to 9 into probability that x equal to 4 plus 90 into probability that x equal to 6, and find the mean and variance of capital X. So we have given the relationship between three values of probability mass function, and as we know, the probability mass function of a Poisson random variable is e raised to minus lambda, lambda raised to x by x factorial. X is 0, 1, 2 and so on. So we have to put we have to find out these probabilities using this formula of probability mass function, and we will keep lambda as it is. And as I discussed, mean is also lambda and variance of a distribution is also lambda. So we have given this probability that x equal to 2 equal to 9 into probability that x equal to 4 plus 90 into probability that x equal to 6. So first we put x equal to 2 here. So this probability is nothing but e raised to minus lambda, lambda square by 2 factorial equal to 9 times. To find out this probability, we have to put x equal to 4 here. So it is e raised to minus lambda, lambda raised to 4 by 4 factorial into 9 plus 90 into probability that capital X equal to 6. So here we put small x equal to 6 and we obtain e raised to minus lambda, lambda raised to x by 6 factorial. Now e raised to minus lambda is common in each term, so that will be cancel out. This we can write as lambda square by 2. This is 9 lambda raised to 4 divided by 4 factorial, and 4 factorial is nothing but 24. 4 into 3 into 2. Here I have kept 90 as it is into lambda raised to 6, and 6 factorial is nothing but 6 into 5 into 4 into 3 into 2. Now here you can cancel out these things. There is 3 common here. Okay, so 3 into 3 9 and 8 into 3 24. Similarly, if you take 6 into 5 into 3, that is going to be 90. So 90 will cancel out and we are left with lambda raised to 6 by 8. Here 3 lambda raised to 4 by 8 and here lambda square by 2. Now again in these 3 terms, lambda square by 2 is common, so that we can cancel out. So if we cancel out lambda square by 2, we will have 3 lambda square by 4. Here lambda square will cancel out and 2 will cancel out. Similarly, lambda raised to 4 by 4. So and this 4 can be taken on left hand side. So we have lambda raised to 4 plus 3 lambda square minus 4 equal to 0. And this equation is nothing but quadratic equation in lambda. Okay, this we can rewrite as square of lambda square plus 3 lambda square minus 4 equal to 0. So this is nothing but quadratic equation in lambda square, and we know the formula for solving quadratic equation. So lambda square is nothing but, if we recall the formula for solving quadratic equation, it is minus b plus or minus under root b square minus 4ac divided by 2a. So using this formula, you can see here b is 3, so minus b is minus 3, plus or minus square of b, that is 9, a is 1 and c is minus 4, so minus minus plus 4 into 4, and minus 3 plus or minus, this is 9 plus 16, that is 25, and the square root of 25 is 5. So if you take positive sign, we have minus 3 plus 5 by 2, that is 2 by 2, which is 1, and if you take negative sign, it is minus 3 minus 5, that is minus 8 by 2, that is minus 4. But lambda is real number, so lambda square can never be equal to minus 4. So lambda square is not equal to minus 4 for any real number lambda. That means lambda square must be equal to 1. And if lambda square is 1, lambda is plus or minus 1. But lambda is positive, so therefore lambda equal to 1. So the mean and variance of x is mu equal to sigma square equal to 1. Because we know that mean is lambda and variance of x is also lambda. So I hope you understand this lecture. What we have shown in this lecture, that the mean and variance of a Poisson distribution are equal to lambda, where lambda is the parameter of the distribution. Parameter of Poisson distribution. So I hope you like this lecture. You can remember this formula, and it is simple. Mean and variance are equal and their equal value is lambda. So I stop here, and I request you to subscribe my channel if you are watching this channel first time. Thank you very much.